Welcome. Come on in and get comfortable.
Mhm.
I want to start our deep dive today by posing a question that kind of challenges the foundation of a lot of what we assume about electromagnetism.
It's a big topic.
It really is.
Mm.
If you are familiar with standard Maxwell equations and, the electron drift models we rely on to understand circuitry, they present a very specific, highly structured picture of how energy moves. But what if the fundamental geometric assumptions underneath those models are completely backwards?
It is a massive question,
Yeah.
but a really compelling one to ask. I mean, we spend so much time optimizing our current models
Hmm.
that we rarely step back to question the geometric constraints we've built them upon.
Right.
So today, we're going to examine a perspective that completely flips that standard architecture inside out.
Yeah. So our mission for this deep dive is to explore something called the emotion model. And the overarching goal of these texts is to completely rethink the role of physical conductors and the fundamental nature of magnetic polarity. Now, the authors make some incredibly bold claims here,
They absolutely do.
and we're going to test those claims against the standard physics we use every day, but rather to investigate the geometry of the world around you through this totally alternative lens.
The sources are asking you to reconsider the bedrock mechanics of how power moves, how magnetic fields actually organize themselves, and what is structurally happening when energy propagates through a system.
Which means tossing out some old assumptions.
Exactly. It requires putting aside the assumption that the physical hardware is the primary actor in an electrical system.
Okay, let's unpack this. Let's start with the conductor itself.
Yeah.
In the conventional view, the copper wire is the star of the show. Right? Standard theory models electricity as electrons propagating through the crystalline lattice of the wire. And the magnetic field that forms around that wire is generally treated as, well, just a secondary byproduct, like a resulting consequence of that internal current.
What's fascinating here is that the authors point out some of the greatest foundational minds in the history of electricity actually questioned or completely disagreed with that standard view.
Really? Like who?
The texts specifically reference Michael Faraday and Nikola Tesla.
Wow. Heavyweights.
Yeah, you can't get much bigger. Faraday famously believed that the magnetic lines of force surrounding electrical conductors were real physical structures in space, not just, mathematical abstractions used to calculate flux.
And the texts note that Tesla described the motive force as circulating primarily around the wire, rather than exclusively through it. The authors of the motion model formalize this into what they call a field-first architecture.
Precisely. In the field-first perspective proposed by these sources, the magnetic field loops surrounding the conductor are the primary dynamic engines of the system. The wire itself isn't the active driver. It is simply a geometric facilitator. It provides the necessary physical pathway that allows those magnetic loops to exist, to organize, and operate. So the wire is merely the environment. The field is what is actually doing the structural work.
So to ground this, the texts bring up the twisted wire anomaly, which I think is a great stress test for the standard model.
It is.
Because if you take two ordinary copper wires, strip the ends, and just crudely twist them together by hand, the circuit still functions perfectly fine.
Right, the light bulb still turns on.
Exactly. But structurally, you've just destroyed the continuous crystalline lattice of the metal. You've created a messy, fractured connection point. Under standard electron drift theory, breaking that lattice should create massive scattering and severe disruption to the flow. But in practice, it doesn't. Why does conduction survive such a crude mechanical disruption?
The emotion texts argue that conduction survives that messy splice because the field survives. If the copper wire is simply a scaffold establishing a field-first connection, the integrity of the internal atomic lattice is secondary.
It doesn't matter as much.
Yes. Once those copper ends physically touch, even in a highly fractured, improvised way, the atomic scaffolds are close enough to propagate a single, continuous domain of field around the exterior.
So the material is just a bridge for the field loops.
According to the sources, yes. Once that continuous external field domain is established across the splice, the surrounding loops of force can exert what the texts call a radial compression relaxation behavior.
Let's pause on that term, radial compression relaxation. What does that physically look like in this model?
Imagine the invisible magnetic loop surrounding the wire actively squeezing inward toward the conductor and then releasing, pulsing in a coordinated way along the length of the wire.
Like a heartbeat almost.
Sort of, yes. This organized radial squeezing and releasing by the field is what the authors claim we are actually observing as continuous electrical flow. The physical wire just allows that field structure to remain coherent across the gap.
Here's where it gets really interesting. Because if the field is the primary structure and the wire is just the scaffold holding it, then the physical shape of the wire dictating that field becomes the most critical variable.
Absolutely.
And the sources spend a lot of time critiquing our reliance on standard uniform cylindrical wires.
They do. Think about a straight wire with a uniform diameter. It produces magnetic loops that are geometrically identical along its entire length. Every segment of that uniform wire generates the exact same field pattern.
Just circles on top of a circle.
Exactly. And the texts argue that this creates an effectively stagnant, passive cylinder of magnetic force.
Because there is no structural variation. You have no usable internal gradients. If every loop of the magnetic field is exactly the same size and shape, there is no change in pressure or geometry as you move down the axis. You completely lack that radial compression relaxation motion.
And the texts draw an interesting parallel to biological systems here. They note that you can easily observe active compression relaxation transport in biology. Think of peristalsis in food transit, or the way blood vessels transport fluids.
Right, nature is always moving things with pressure gradients.
Nature constantly uses geometric gradients and pulsing contractions. But in our engineered uniform wires, we force the field to be completely static and structurally repetitive.
Now, a standard counterargument here would be the solenoid. If a straight wire produces a stagnant field, we usually just wind that uniform wire into a coil or a spiral to concentrate the magnetic force. Does that solve the geometric problem according to the emotion model?
The sources challenge that directly. The authors argue that spiraling a uniform wire does not magically create a true structural vortex in the field. It is a mechanical illusion.
An illusion. How so?
Because you are only rearranging the physical metal. You haven't fundamentally altered the local magnetic field pattern generated by the wire itself. Each segment of that coiled conductor is still just producing those identical, stagnant circular loops around its own local axis.
I see. The texts point out that coiling actually misaligns the loops relative to the overall system. When you coil a uniform wire, the individual magnetic loops have their edges, rather than their faces, aligned with the primary direction of electrical flow. The spiral exists entirely in the physical copper, not in the underlying field geometry.
Which brings us to a massive, real-world consequence. Heat.
Yeah, let's talk about heat.
We generally accept heat in electrical systems as an unavoidable fact of physics. It's standard I²R resistive loss. But the emotion model frames heat entirely differently. The texts point out that nature tends to run her highly energetic systems cold, while human-engineered devices almost universally run hot.
This is a radical reframing. The authors are suggesting that heat isn't just an unavoidable friction penalty, it is a diagnostic indicator of geometric inefficiency.
That is the core argument.
Right.
When the uniform geometry of our devices fails to support coherent, self-organizing field motion, the energy becomes disordered. Because the field is forced into stagnant, identical loops without a natural gradient to facilitate movement, the energy cannot effectively organize itself into structured forward motion.
So it just kind of spills out.
Exactly. It dissipates laterally as thermal waste. According to the texts, heat is the system physically demonstrating that its geometry is fundamentally misaligned with how energy actually wants to move.
So if uniform cylinders are the problem, what is the geometric solution? The sources introduce the concept of a tapered conductor, a geometric gradient. Instead of a uniform cylinder, the wire needs to be wider at one end and progressively narrow toward the other. The text specifically suggests sympathetic sequences, like a taper moving from 4 millimeters down to 1 millimeter, perhaps arranged in a sequence like 4-1-1-4. Can you visualize for us what that physically means? Are we talking about stepping down the diameter in specific ratios?
Yes. Physically, imagine a wire that starts at 4 millimeters in diameter. It gradually tapers down, like a funnel, until it is 1 millimeter thick. It holds that 1 millimeter diameter for a segment, and then progressively expands back out to 4 millimeters. By introducing that physical taper, that physical nozzle, you force a compression gradient directly into the surrounding magnetic field.
Because the magnetic loops have to conform to the scaffold?
Exactly. Instead of stagnant, identical circular loops, the external magnetic loops are now structurally motivated to shrink, compress, and accelerate as they move down the narrowing axis. The text compares this structural merging to how carbon loops hybridize in a benzene ring. The individual magnetic loops merge their identities into a communal helical geometry.
The sources use the hurricane as the ultimate analogy here, pointing out that this tapered vortex is nature's preferred transportation architecture. We see it in hurricanes, tornadoes, whirlpools, and high-energy plasma filaments.
It is an incredibly apt geometric analogy. Think about the mechanics of a hurricane. As the radius of the storm circulation decreases toward the eye, the rotational velocity of the wind increases and the internal pressure drops significantly.
It's all about that gradient.
Right. The energy is organized and transported through compression and circulation, not simply pushed linearly through a pipe. Those swirling loops create a beneficial pressure gradient that actively aids in the transport of the system's mass and energy.
The authors are arguing that a tapered conductor creates that exact same internal pressure dynamic for electromagnetic fields. It allows those disjointed magnetic loops to hybridize into a coherent, funnel-shaped vortex structure. If you utilize radial compression, the energy transport becomes highly efficient, dropping the thermal waste.
And if we follow the logic of the source texts, if changing the physical geometry of the conductor completely changes how the field organizes and behaves, this same principle must fundamentally change how we interpret magnetic polarity itself.
Which brings us to the bar magnet. This is perhaps the most controversial claim in the source material.
It definitely turns things upside down.
Because the rectangular bar magnet is the absolute bedrock of how we teach and visualize magnetic polarity. But the E-motion model asserts that the bar magnet is not a neutral representation of nature at all. They call it a manufactured container.
To understand that claim, we have to look at how a standard bar magnet is created. To magnetize that rectangular block of metal, it is typically wrapped in coils of copper wire to polarize it. But crucially, as we discussed, those coils are wound uniformly. The wire has the same diameter, and the coils have the exact same spacing from end to end.
So the manufacturing process itself forces the field into an artificial posture. Because the energizing coils are uniform, the resulting permanent magnet presents a flat, straight axial gradient.
Yes.
The loop faces are turned 90 degrees, aligning their edges with the poles. It creates a highly uniform, highly parallel field along the axis. But the texts argue that natural, unconstrained fields rarely express themselves as straight parallel lines. Nature defaults to variable radiuses, tapering geometry, and compression gradients.
The sources draw a very sharp parallel here to the famous single-slit and double-slit experiments in quantum mechanics.
Oh, that's a great comparison.
In those experiments, if you change the physical aperture, the structural constraint, you completely change the observed outcome, shifting from a particle-like band to a wave-like diffraction pattern. The authors argue the bar magnet is doing the exact same thing to the magnetic field. The rectangular shape is an arbitrary geometric constraint that truncates and severely limits what we are able to observe.
This brings us to the most radical takeaway from the deep dive. If the bar magnet is essentially an artificial aperture suppressing the natural circulatory pathways of the field, what happens to the golden rule of electromagnetism? According to the authors of these texts, what we perceive as north-south attraction is actually an illusion created by the magnet's shape.
Let's break down the mechanics of why they claim it's an illusion. To understand this, the texts ask us to look at how bodies naturally move within any field. They use examples like protein separation and gel electrophoresis or standard chromatography techniques.
Okay.
In every natural scenario, particles or entities migrate until they find a condition of minimal potential tension with their environment. They follow a permission gradient.
Meaning they move where the environment structurally permits them to move with the least resistance.
Yes. The text points out it is the exact same reason the Earth doesn't just crash linearly into the sun, but rather circulates in a stable orbit of minimal resistance. Like conditions seek like conditions, provided there is a geometric permission gradient allowing them to align.
A North Pole naturally wants to seek out and achieve structural continuity with another North Pole, but they don't want to align side by side or crash head-on. The texts claim they want to align with a 0-degree offset.
The authors use an excellent visual analogy to explain this 0-degree alignment, stacking traffic cones. A North Pole actually wants to nest completely inside another North Pole to form a coherent, continuous compression gradient. Just like dropping one orange traffic cone onto another, like polarity seeks structural nested continuity with, like, polarity.
But if North wants to stack with North, I have to play devil's advocate here.
Go for it.
If I take two standard bar magnets and push the North Poles together, they violently repel. And if I flip one around, North and South instantly snap together. How does the emotion model explain that physical reality if like seeks like?
The authors argue that what we call repulsion and attraction are actually structural roadblocks caused by the bar magnet's rectangular solid geometry.
Mm.
When you push two north poles together head-on, their internal fields are essentially 180 degrees misaligned. They are trying to flip around to achieve that 0-degree nested traffic cone alignment.
Right, but they can't.
Exactly. The flat, solid faces of the magnets prevent them from completing that path. The field essentially buckles sideways under the compression, and we observe that buckling as repulsion.
Okay, then what is happening when a north pole approaches a south pole? Why do they stick?
Remember that the internal field lines of a magnet run from south to north. When a north pole approaches a south pole, the field lines are finally at that preferred 0-degree alignment. The external north pole is actually trying to enter the south pole to travel through the interior of the magnet, to get inside and physically stack with the internal north pole at the other end. It wants that nested traffic cone architecture.
But it physically can't get inside. The solid rectangular block of the magnet itself blocks that natural pathway. The south pole lacks the necessary physical entry point or hollow gradient for the field to naturally stack.
Exactly. So the north pole effectively crashes into the solid barrier of the south pole. It is structurally blocked from reaching its destination, but because the field lines are perfectly aligned at 0 degrees, they remain locked at that roadblock. The texts argue that for hundreds of years, we have observed this interrupted pathway, this geometric roadblock, and incorrectly labeled it attraction.
We're seeing two things stuck against a barrier, trying to move through each other and assuming they just want to touch surfaces.
According to the texts, yes. We are observing the constrained behavior of a manufactured dipole container and mistaking it for a fundamental law of physics.
There is a highly specific detail in the sources regarding stainless steel that the authors use to prove this point. We know two north poles normally repel, but the texts note that if you place a piece of stainless steel between those same two repelling north poles, they will both strongly attach to it.
That's right.
And they will attach perfectly straight, neutralizing the repulsion. If they inherently repel each other, why does the steel bridge fix it?
The emotion model explains this by looking at the internal geometry of the stainless steel. The steel acts as a structural bridge. It provides a highly compatible internal environment that allows those two opposing head-on fields to seamlessly and coherently spiral around one another.
Like weaving them together.
The text described this interaction as being exactly like a nut winding onto a screw. The stainless steel provides the structural permission path that the direct, flat north-to-north interaction lacks. It allows the fields to intertwine coherently without buckling.
If the authors are correct, it implies that if we had historically manufactured permanent magnets as hollow, tapered cones instead of solid rectangular bars, the north pole of one magnet might just pass right through the south pole of the other to align seamlessly internally. It would form a continuous compression gradient instead of snapping together flatly.
That is the implication. By changing the container geometry from uniform cylinders and flat rectangles to compression gradients, the authors argue we would reveal nature's true, unconstrained behaviors.
So what does this all mean? For you listening, engaging with these source texts means temporarily suspending the assumption that polarity is merely a static property of isolated endpoints, like a fixed positive and negative terminal.
It's a huge shift in perspective.
The emotion model asks you to view polarity as a property of permitted pathways of circulation within a much larger field. It raises the distinct possibility that some of our most fundamental scientific models have been unintentionally constrained by the artificial geometry of the very tools we built to study them. We've been looking at magnetic reality through a perfectly square people, and subsequently assuming the entire universe must be built out of boxes.
If we connect this to the bigger picture, it forces a profound reevaluation of how we physically interact with energy. The texts heavily emphasize that nature relies on compression, circulation, and helical gradients to move energy efficiently. When we force massive amounts of electrical energy through unnatural uniform geometric containers, we generate immense inefficiency, structural disorder, and thermal waste.
Which leaves us with one final, massive thought for you to ponder today as you look around at the devices plugged into the walls of your home or office. If the authors of these texts are correct, and human engineering has spent the last century forcing energy through inefficient, uniform geometries that generate staggering amounts of waste heat, What would happen to our global power grid, our electric vehicles, and our entire technological infrastructure if we completely redesigned them from the ground up?
It would change everything.
What if we stripped out the uniform cylinders and replaced them with nature's preferred tapered, hurricane-like vortex geometries? Could we effectively eliminate energy loss as we currently understand it?
It is a profound engineering possibility. It suggests that our ongoing global energy crisis might not strictly be a problem of how we generate power, but fundamentally a problem of the rigid geometry through which we permit that power to move.
A huge thank you to you for joining us on this deep dive. Keep questioning the geometry of the world around you, and we will catch you next time.